In this video, we're going to continue on with multiplying and dividing radical expressions, and we're going to talk about rationalizing the denominator of a radical expression. So when we're simplifying radical expressions, we do not want to leave a radical in the denominator of a fraction. So sometimes you'll simplify and you'll have a radical in the denominator like this, and you need to multiply the numerator and denominator by a radical with the same index that you're using. So if you're at square roots, continue in square roots. If you're in third roots, continue in third roots, so that you produce a perfect nth root. So if it's in square roots, perfect square, or if it's in cube roots, perfect cube, or so on and so forth. Perfect nth power, so that you can simplify it. So for example, if I have 2 over square root 5, I can't take the square root of 5. So what I want to know is, what can I take the square root of here that would make sense that I could then simplify? Well, square root 5 doesn't work, but could I multiply 5 times something to get it to be a perfect square root? And the answer is yes. I could multiply by 5 and it would become square root 25, so by radical 5. And then I have to do that in the numerator and denominator, so it doesn't change the overall value, because square root 5 over square root 5 is 1. So then what I end up with here is 2 square root 5 over square root 25, which gives me 2 square root 5 over 5. And now I no longer have a radical in my denominator, and I'm good to go. So here, cube root of 4 over 9, that's really the cube root of 4 over the cube root of 9. There I go with those 4's again. So again, I'm trying to turn 9 into a perfect cube number. So what could I multiply by? Well, think about, how do I get that to be a perfect cube? That's right, I'm going to multiply by the cube root of 3, numerator and denominator. And so now what I have is the cube root of 12 in my numerator, the cube root of 27 in my denominator. And so then when I simplify that, I have the cube root of 12 in my numerator and just 3 in my denominator, and I'm good to go. So these are just similar to those. So this gives me square root 5 over square root 11. Square roots are probably the less complicated ones to rationalize, because typically speaking you just multiply it by whatever you have there. So square root 11 over square root 11. What I now have then is square root of 55 over the square root of 121, which gives me square root of 55 over 11. Now you may see the 55 and 11 and think, hey, I want to simplify that, but remember this is the square root of 55, and the 11 is not in the square root. When you have higher powers, it's a little bit tricky. Okay, so here again, what is 8 when we're thinking about powers? Well, 8 is really 2 to the 3rd. And what I want it to be would be 2 to the 5th, so that I could take the 5th root of it. So if it's currently 2 to the 3rd, how many more do I need? Well, I need 2 more, so I need to multiply it by 2 squared, which would be 4. All right, so then what this now gives me is the 5th root of 28 over the 5th root of 32, which gives me the 5th root of 28 over 2. And that's how we're rationalizing the denominator. A couple more here to look at and practice. If you have a variable, same thing. When we're doing square roots again, it's pretty much just multiply by whatever the square root is. So this gives me 6 square root of x over the square root of x squared, which gives me 6 square root of x over x. Again, cannot cancel those x's, because this one up on top is inside the radical and the one down here is outside. I'm dealing with perfect cubes here, so I have the cube root of 10 and the cube root of 9y. Now, what I am thinking, okay, is I'm going to multiply by the cube root of something over something. It's got to be the same. And my goal would be that my denominator would be a perfect cube, so that I can simplify it, right? So 9 is 3 squared, so I multiply by one more 3, and that's going to give me 3 to the third, or 27. Here I have a y, and I need it to be a perfect cube, so I need 2 more y squared, and that will give me y to the third. So numerator and denominator by 3y, cube root of 3y squared. So my numerator becomes the cube root of 30y squared. And I set this up because I want it to simplify that denominator, so I no longer have radicals. And so my denominator becomes 3y. Oops, 3y. Okay. Think about this next one for a minute. See if you can come up with something. 4th root over 4th root. And remember, we want it to simplify. So think about how these numbers already look in terms of powers. Okay, so 8, that's 2 to the third. I need a 4th power, so I need to multiply it by one more, which would give me a 2 to the 4th. My x, I already have 3 of them. I need one more, which would give me an x to the 4th. Similarly, my y's, I have 2 of them. I need 2 more, and that would give me a y to the 4th. So 2xy squared. We're taking the 4th root of that. So this becomes 4 times the 4th root of 2xy squared over the 4th root of 2 to the 4th, x to the 4th, y to the 4th. So it's 4 times the 4th root of, it's doing pretty good there for a minute, 2xy squared over 2x and y. One last step. I have a 4 here and a 2 here. That can simplify. And so because it can simplify, I need to simplify it. And so 2 goes in here twice and 2 goes in here once. So my final simple answer is, simplified answer is 2 times the 4th root of 2xy squared. Make sure your radical symbol goes all the way over that because it's all on the inside. And then I have 1xy, or just xy, in my denominator. So that's how we rationalize denominators when there's one term in them. Okay, keep up the good work. See you in the next one.